Good evening, friends. Uh, since we are discussing the molecular orbital theory nowadays, we have seen lots of molecules. We are now near to end of this chapter. We have seen homonuclear diatomic molecule. We have seen heteronuclear diatomic molecule. Today, we will see heteronuclear triatomic molecule. Heteronuclear triatomic molecule like NO3, NO2, CO2, NO2 minus, etc. Such type of molecules are called like the heteronuclear triatomic molecule. Today we will see the heteronuclear triatomic molecule, that is CO2 molecule, that is carbon dioxide molecule. We are now in the molecular orbital theory. With the help of molecular orbital theory, the bonding in heteronuclear triatomic molecule, like simple molecule like NO2, CO2, NO2 minus, etc. This molecular orbital theory is explained very well manner. So the atom, let's write the electron configuration of this CO2 molecule, or the atoms that are involved in this molecule are carbon and oxygen. We know that carbon, atomic number 6, the electronic configuration will be 1s2, 2s2 and 2p2. Oxygen, which is having atomic number 8, the electron configuration will be 1s2, 2s2 and 2p4. Now, this 1s orbital of carbon atom is very low in energy, therefore it will not take part into the bonding. 1s orbital of oxygen atom is also very low in energy, therefore they will not take part into the bonding. So this 2s and 2p orbital of carbon and 2s and 2p orbital of oxygen, there are two oxygen atoms in this molecule, two oxygen atom in this molecule and one carbon atom in this molecule, one carbon atom in this molecule. Therefore one carbon atom, total 4 number of electron from the carbon atom, and this 2s and 2p4 for the oxygen. Therefore this comes out to be total 6 electron of one oxygen atom plus 6 electron from other oxygen atom. Therefore total 6 plus 6, that is equal to 12, plus 4, that is equal to total 16 electrons are involved in this molecular orbital diagram of this CO2 molecule, right? 16 electron. Out of these 16 electrons, this 2s electron of this oxygen atom, each of the oxygen atom remains non-bonding, remains as it is, since they are very low in energy. They are very low in energy. Therefore, 2 electron from one oxygen atom, 2 electron from other oxygen atom, total 4 electron will be as it is in the molecular orbital. Therefore, total only 12 electrons are involved in this molecular orbital diagram of this CO2 molecule. Now, there are two types of bonding in the CO2 molecule. This CO2 molecule, carbon, oxygen, carbon and oxygen. One pi sigma bond, one pi bond is involved. Another carbon and oxygen, between carbon and oxygen, one sigma bond and another pi bond is involved. Beside this, there are non-bonding as well as antibonding molecular orbitals are there. Non-bonding and antibonding molecular orbitals are there in this molecule, in this CO2 molecule. Let's try to explain this with the help of molecular orbital theory. I have already drawn the diagram for this picture diagram for this molecular orbital diagram of CO2 molecule. So let's explain one by one. I am copying this into our regular whiteboard pattern. Wait for a moment. So I hope everybody can see this. So molecular orbital diagram in heteronuclear triatomic molecule. This thing I already explained. Formation of sigma molecular orbital in CO2 molecule. Sigma molecular orbital formation in the CO2 molecule. 2s orbital of carbon atom with the 2pz orbital of one oxygen atom and 2pz orbital of other oxygen atom combined together to form the sigma 2s bonding molecular orbital. Sigma 2s bonding molecular orbital. This is 2s orbital of one oxygen atom and 2pz orbital of other 2s orbital of one carbon atom, 2pz orbital of other oxygen atom, 2pz orbital of other oxygen atom combined together, which forms the sigma 2s bonding molecular orbital. Sigma 2s bonding molecular orbital. Now, why this z orbital? Since this 2s orbital is in spherical in nature, therefore which can be combined in any direction. Therefore, for our suitability, it is taken as the 2pz orbital. Actually, 2px orbital, 2py orbital, any orbital can be combined. For our suitability, we are saying that 2pz orbital combining together, which form the sigma 2s bonding molecular orbital. Another type of bonding which is present in this molecule is 2pz orbital of carbon atom, 2pz orbital of carbon atom with 2pz orbital of one oxygen atom number 1 suppose, and this is oxygen atom number 2, 2pz orbital of other oxygen atom. So this orbital is 2pz orbital of carbon atom and this orbital is 2pz orbital of one oxygen atom and this orbital is 2pz orbital of another oxygen atom number 2. Let's say oxygen atom number 2, and it forms the sigma 2pz bonding molecular orbital. So sigma 2s orbital to sigma 2s bonding molecular orbital, sigma 2pz bonding molecular orbital. Now next type of bonding which is present in the CO2 molecule is sigma anti-bonding molecular orbital. We know that the number of atomic orbital taking part into the bonding, that is equal to number of molecular orbital those are forming, right? So this is the 2s orbital of the carbon atom and 2pz orbital of the one oxygen atom. This is 2pz orbital of one oxygen atom and 2pz orbital of another oxygen atom. Suppose oxygen atom number 1 and this is oxygen atom number 2 orbital, 2pz orbital, and they form the sigma star 2s antibonding molecular orbital. Sigma star 2s antibonding molecular orbital, right? So we'll go in the next lecture, next slide. We'll go in the next slide. Wait for a moment. Copy, paste. So next one is the formation of sigma star 2pz molecular orbital. 2pz molecular orbital. 2pz orbital of one carbon atom. Previously we were using 2s orbital of the carbon atom. 2s orbital of the carbon atom. Now we are using 2pz Z orbital of 2p Z orbital of carbon atom. There is formation of sigma star antibonding molecular orbital, right? So 2p Z orbital of carbon atom with 2p Z orbital of one oxygen atom, 2p Z orbital of another oxygen atom. This is the 2p Z orbital of one carbon atom, and this is the 2p Z orbital of another one oxygen atom, and this is the 2p Z orbital of another oxygen atom. Therefore, which is forming antibonding sigma star 2pz, sigma star 2pz molecular orbital, that is antibonding molecular orbital, right? Now these are the sigma bonding and antibonding molecular orbital. Sigma bonding and antibonding molecular orbital we have discussed till now, right? Next type is formation of pi molecular orbital in the CO2 molecule. Formation of pi bonding molecular orbital. Now, formation of pi bonding molecular orbital will take place. Those are having similar sign. The orbitals those are having similar sign, or those are which are in phase. This is the orbital of 2px orbital of carbon atom. This is the 2px orbital of one oxygen atom. This is the 2px orbital of another oxygen atom. They are forming the pi to px bonding molecular orbital. Pi to px bonding molecular orbital. Remember that. Now, next step is formation of antibonding molecular orbital. Pi antibonding molecular orbital. In previously, sigma bonding and sigma star antibonding molecular orbitals were forming. In this case, the pi star antibonding molecular orbital are formed. Those atomic orbitals are out of phase. Those atomic orbitals are out of phase. This is the 2px orbital. This is the 2px orbital of the carbon atom, 2px orbital of the oxygen atom, 2px orbital of the another oxygen atom. They are forming pi star 2px anti-bonding molecular orbital. This was the pi bonding molecular orbital, pi 2px bonding molecular orbital. This is the pi star 2px anti-bonding molecular orbital. Next, formation of non-bonding molecular orbital. The formation of non-bonding molecular orbital takes place when the bonding and anti-bonding mutually cancel out and it is obtained by the zero overlap. This orbital 2px orbital, 2px orbital, 2px orbital, whenever there is a zero overlap, in that case this pi non-bonding 2px atomic orbital, pi non-bonding 2px atomic orbital. Since 2px 2py orbitals are equivalent, we get the pi 2py bonding, pi 2py bonding, pi star 2py anti-bonding, pi star pi 2py non-bonding molecular orbital. So there are three types of bonding in this CO2 molecule. One is the bonding molecular orbital, another one is the non-bonding molecular orbital, and the last one is the anti-bonding molecular orbital. Right. Now this is the molecular orbital energy level diagram. Molecular orbital energy level diagram for CO2 molecule. Molecular orbital energy level diagram for CO2 molecule. Now, the electrons, as I have told you that these are the 2s electron. These two electrons from the one oxygen atom, two electrons from the another oxygen atom. They remain as it is since they are lower in energy. Right. Now, in the 2s orbital of this carbon atom, there are two electrons. In 2p orbital of each of the oxygen atom, there are 2p 4 electron. The energy level, these energy levels are degenerate one. Degenerate means the atomic orbitals, those are having equal in energy. Now the orbitals that are formed in this orbital, is sigma 2s bonding molecular orbital, and this orbital is sigma 2pz bonding molecular orbital, sigma 2pz bonding molecular orbital, and this orbital is uh, pi 2px bonding molecular orbital. Another orbital is pi 2py bonding molecular orbital, as we have seen sometime before. Bonding and anti-bonding molecular orbitals are forming. This orbital is pi 2py bonding molecular orbital. Now this orbital is pi pi 2px non-bonding molecular orbital. This orbital is pi 2py non-bonding molecular orbital, right? So in CO2 molecule, there is oxygen, carbon and oxygen bond. Between this one oxygen number 1, let's say this is oxygen number 2, let's say one bond is sigma bond, another bond is pi bond. One bond is sigma bond, another bond is pi bond. One bond is sigma. Therefore in CO2 molecule there are two sigma bond and two pi bond. I hope you have understood this diagram, but remember that the energy level diagram for this CO2 molecule is very important as your career point of view. Remember that. Next molecule we will be studying NO2 molecule, right? Till then, bye bye, enjoy the lockdown.